Good evening, everyone. It is once again Ted the Speed Learner, and once again I'm going to cover the topic of Bezier curves, specifically quadratic Bezier curves. And the reason for that is that I actually took some time and I studied them a little bit deeper, and I have additional information that I felt you guys really needed. I actually posted this on my Speed Learner fan page, and if you want a link to that, you can go ahead and ask me. But before I get into this, I wanted to let you know that I have published 5 Kindle books, and if you want the links to any of those, please let me know. I'll get those links to you just as quick as I can. Also, many of these videos, and I will have cards on this video here so you can go ahead and take a look at those previous Bezier curve videos. I will now have cards on the upper right corner of the screen, but on top of all of that, I will also have end screens where you can actually see some of these previous videos and so on and so forth. You can click them and take a look and so on and so forth. Okay, enough of that. Let's get to the meat and potatoes of this particular video. We're going to do some drawing here, and it's very important that you see this, because once you master the Bezier curve, what's going to happen is that you're going to be able to draw full-blown SVG, and it's going to look great. It really is. But you have to understand this, you have to comprehend it, or it's not going to work. Now, first of all, we're going to draw 2 lines. As you can see here, you have 2 lines of a triangle. Okay? Now, we have a point A and a point B. These are known as control points. And whoops, that's the wrong one. Sorry, not B, C. Okay? You have A, you have C. These are called control points. This is also going to be a control point, and it's going to be called B. Why do we have 3 control points? A, B, and C. Why do we have them? Okay, we're going to draw a curve. Now, in this case, we're going to actually draw a circle. And there is a reason for this. And it's going to be the most lopsided circle you have ever seen. That is probably the ugliest circle you've ever seen. This looks more like an ellipse than an actual circle, but I went ahead and drew this way for a reason. Okay? Now, do you guys remember a long time ago when I discussed tangents? And I specifically told you that a tangent is nothing more than a straight line that touches a circle or a curve, either one, at exactly one point. That's important. Okay? And I'll explain why that is important in just a minute. But anyway, there you go. Alright, so what you have here is you have line AB, and it is actually tangent to this, well, I'll call it an ellipse because that's really more what it is than an actual circle, but anyway, ellipses qualify too. So this line AB is tangent to this ellipse. Line BC is also tangent to this ellipse. I know it doesn't exactly look like that, but it is. Anyway, so what happens next? Alright. You have a third line, and it starts from line AB at point D. It goes to line BC, and it stops at point E. But what about this point right here? Well, this line, this DE line, is actually tangent to this ellipse. And it has to be. And I'll explain that in a minute. But anyway, so the point which touches the point of DE, the point of line DE that actually touches this ellipse, it's called F. I know this is one of the poorest drawings you've ever seen in your life, but we're going to go on with it anyway. But that point is F. Okay. Now, you have to imagine at this point that line DE is nothing more than a seesaw. You guys know what a seesaw is. Okay. And the center of that seesaw is point F. Okay. Now then, what happens is, as line DE, which will always touch this ellipse, okay, as line DE always touches this ellipse at exactly one point, first, the line AD is short. It's very, very short because the seesaw goes down here, like this. The seesaw goes down like this. Alright? So first we start with AD being real short. But AD actually gets longer and longer. Why? Because this line goes up and up and up and up. Okay? Point D goes up, so this line is going to seesaw the opposite way. Eventually it's going to look like this. Okay? And when the line looks exactly like this, and I'm trying to show this to you the best way I can, when the line looks like this, it's actually going to be D is actually going to be right on top of B. That's right. So as line AD gets bigger, line BE will also get bigger, and line DF will also get bigger. Okay? So what that means is that line AD will be the same length as line BE and as the same length as line DF. Okay? So as line AD gets larger, BE also becomes larger, and DF also becomes larger. Okay? So what it is like a seesaw. It turns from one end to the other. And that's how that works. And as it goes from one end to the other, F will continue to touch this line here at one single point. This curve will be touched by DE at point F at various points along the curve. And that's how you draw the actual curve. Okay? The point F will show you, because you're going to have a whole bunch of point Fs, and if you draw a line around that goes through all those point Fs, you will have that curve. That's how that works. The tricky part isn't drawing this like this. The tricky part is coming up with the coordinates that you're going to need on a graph paper. Okay, if you have graph paper, you're going to have to plot points. That's when it starts getting tricky, because you have to find the x coordinate and the y coordinate of A, D, B, E, C, and F. That's when it becomes fun, and it takes a lot of calculations to do that. I will cover that in a future video. Alright? And so, as soon as I do, I will let you know. Alright, so, in the meantime, I want to thank you for watching this presentation. I will tell you more in a future video, so I'd like for you to stay tuned.